Hey guys, today's question is move pieces to obtain a string. In this question, we are given with two strings, start and target, and both of the strings contains only these three characters L, R, and underscore, where L in the start strings represent that it can be moved to the left side and R represent it can be moved to the right side. So L and R some objects, and underscore is the empty space. Okay, so now we have to return by doing any number of operations. The start string can be converted into the target string. So we have to return true or false. Now in this example, we can see the start is given as this string and target is this. Now as this is L, so the character L can be moved to the left side only and character R can be moved to the right side only. So we can move this L to the left side, which is an empty space. So it will look like this, the left starting to indexes. Now when we reach this R, we can move it to the right side. So we found this R. Okay, and for this R we can also move it to the right side to place it at the last index, and we move this R to place at the second last index. So the resultant string will look like the same as the target string. So we will return true, otherwise we have to return false. Like in this case, the start is this and target is this. So this is uh, the first character is R. We can move it only here because here it is a left and the left cannot be moved right side. Left can only move left, so R can be moved from here to second index only. But the target string, it is required to R at the last position. So in this in this example, we return false. So now let's see the approach. What we're gonna do is we will simply traverse in the start and target string using two pointers I and j, and at every point when we found a uh, new character other than space, we will check if those characters match or not, because if in the at the first position the first obstacle in the left side, if it is not matching, because let's say it was here it was R rather than L, so we can see the R and L, uh, these characters cannot cross each other. So the R at the left side will always remain at the left side. So position of every character is fixed in the position between the intermediate characters is fixed. Okay, so as there is L, there is R, and here it is a R. So in this between L and R, it cannot be L. Okay, so if the current character does not match the first character that we will see, if it does not match, then we will return false. Otherwise, we will check. Okay, what we will check is if both characters are L. Okay, as in this the current example one, we traverse from the starting. We found the first character L here and the first character L here. Okay, we will use a while loop to discard the underscores. So we see the ith pointer is greater than j. Okay, and in this case we are fine. We can convert this is this part of the string into this part of string. Okay, because the L can move to the left. But if it was reverse, if the L, if let's say if this was the start string and this was the target string, let's assume that. So this L cannot move to the right part and we can't change the start string. So in that case we have to return false, okay? Because L can move to only left. So if we found two L's, okay, in the start and target, if we found the both characters L, and if the start index is less than target index, okay, if the I is less than j, in that case we have to return false. Otherwise we will proceed further. Also in the case when we found the character R, okay, we found character R, if the current index of the start string, which is I, if it is less than j, okay, if it is greater than j, then we can't convert, because if R is at the right side we can move it to only right side. Okay, we can't move it to the left side, so we can't convert start to target if R, if the both characters are R and I is greater than j. Okay, so by following only these three conditions, we will write code, and let's see the code to understand more briefly. So initially let's take two pointers I, two variables I and j. Okay, and now let's run the loop for both. So while the both index are under the size of both strings, so I less than start dot size and j is less than target dot size. While this condition holds, we will do some work. First, we will go to the first character in the L, and also we will go to the first character in the R, which is not underscore. Okay, so let's again use a while loop for that. So while I less than start dot size, okay, and current character at start is underscore, we have to move further, otherwise we will stop. Same for the target string, we have to find the first character uh, which is not underscore. So while j is less than target dot size and start of j double equals to underscore. Okay, in that case you have to increment j. Now after these while loops, if the both index are under control, then we will check if the both index are not out of bound. So first we will check if both index are out of bound or not. So if I less than start dot size and j less than target dot size, in this case both index are in the bound, so we can check the current character is same or not. So first we will check if the both characters are same or not. So if start I not equals to start j, that means there is the both characters are not same. In that case you have to return false because we can't convert that, as I explained before. And now these two cases, if the character is L, okay, in that case the ith pointer which is in the start string should be in the right side, okay, right side or equal to the target. It can't be at the left side of j. Okay, so if start of I double equals to L, okay, and I is less than j, in that case we can't convert these string. We have to again return false. And other case, if the value is right, in that case you have to check the ith pointer should not be at the right side because we can't take the value r to the left side. Okay, so and I is greater than j, in that case we have to return false. Okay, now if we don't found false anything, we will simply increment I and j to proceed further. Finally, after this execution of this while loop, we will return if both indexes are if the both strings are uh, evaluated or not. So we will simply check. So again, another edge case is there if we are remained with underscore. Okay, we are remained underscore uh, in a single string and other string is proceeded, then this while loop will terminate because this is for both the string. So we have to discard those underscores. We will use another while loop and simply check. So while I is less than start dot size and start of I is underscore, okay, we will simply increment I, and while j is less than target dot size and target of I double equals to underscore. So we are just proceeding, we are just traversing all the characters j. Now we can turn the condition. Okay, now if I and j both are out of bound, okay, that means we have successfully traversed whole of the both strings. Okay, then we can return true. So we will simply return that condition if I is greater than equals to start dot size, return I greater than equals to start dot size and j greater than equals to target dot size, because we don't found false anywhere in the loop. Okay, let's run this. Wrong answer. Should I use a bracket here? Okay, wait a second. Double equals to underscore. Mhm. Let's see from the starting. While ls in start and j is in target. While ls in start and start I is underscore. While j is in target and target j underscore. Okay, here it should be target of j. My bad. Let's run again. Okay, what happened? False in this case. Why? Here it should be target of j. Okay, let's run finally. It should get accept. Okay, what's the problem? Here it should be also target. Okay, now please run. Let's see. Okay, let's submit this. So the code is accepted. Thank you for watching.